Hello everybody. Today's video will be about classifying triangles based on their angles and their side lengths. So there are two major ways of classifying them. We're going to talk about 7 different main triangles on the front side of our papers. And then we're going to go over some examples on the back on how to look at a diagram and actually classify these triangles by their sides and their angles. I have my notes already typed up on this sheet. So if you feel like I'm going too fast, then feel free to pause your video at any moment to copy down what I have written down here on the paper. Okay? The first type of triangle we have to look at is a right triangle. A right triangle is simply a triangle with a right angle. So what you're going to look for here is any triangle with one of those right angle symbols, the box, the square, whatever you want to call it. That's a right triangle. And that's really it. That's all a right triangle needs is a right angle. The second type of triangle is an acute triangle. An acute triangle is a triangle with 3 acute angles. So all 3 angles in the triangle have to be less than 90. If that's the case, then you have an acute triangle. The third type of triangle is an obtuse triangle. An obtuse triangle is a triangle with an obtuse angle. So it just needs the one obtuse angle, and that makes it an obtuse triangle. The fourth type of triangle is an equiangular triangle. An equiangular triangle is a triangle with all 3 angles that are congruent. It sounds like equal angles, equiangular triangle. So drawing this, you're going to draw a triangle and then 3 arcs matching to showcase that all 3 angles are the exact same measure. For triangles, it's always going to be 60 degrees in this case. So if you see a triangle with 3 60-degree angles or even 2 60-degree angles, you're going to know that for sure it's going to be an equiangular triangle. All right, so those first 4 are going to be classifying a triangle by its angles. The next 3 are going to be classifying a triangle by its side lengths. An equilateral triangle is a triangle with all 3 sides congruent or equal in length. So if I were to draw a triangle, try to draw all sides the same, each side has 1 tick mark. That indicates that each side has the exact same length. Also, fun fact, if a triangle is equilateral, then it automatically has to be equiangular as well, and vice versa. So if you see a triangle is equiangular, you can assume it's equilateral, or the other way around. If you see an equilateral triangle, you can assume it's also equiangular. Both of those names have equal in it, so it should be pretty easy to decipher what that means. Isosceles triangle. An isosceles triangle is a triangle with 2 sides out of 3 that are congruent. So I draw 2 sides like this, 1, 2, those 2 are the same, the third one is not. That's an isosceles triangle. The last one, a scalene triangle. A scalene triangle is a triangle with no sides congruent. All 3 sides are different. So if I were to draw this, attempt to draw a triangle with 3 different lengths, like that. So we see a triangle with 3 sides, and each one has a different set of tick marks. Then you know for a fact that none of the sides match because none of the tick marks match. All right, just to recap. The 4 on the left, equiangular, right, obtuse, acute. That's how you classify a triangle by its angles. Classifying it by its side length, equilateral, isosceles, and scalene, with the equilateral triangles automatically being equiangular. Examples on the back. So the first section we're going to classify by the side length and or angle measure based on the diagram here. So we need 2 names per triangle. The first one. The first thing I'm drawn to is this box symbol showcasing that it is definitely a right triangle. The second thing I notice is that each side has a different number of tick marks, 1, 2, and 3. So no sides are the same. That leads me to believe that's going to be a scalene triangle. So you can call it a right scalene or a scalene right. That part does not matter. But what's important is that you have those two based on the diagram. Number 2, I have 1, 2, 3 tick marks again, so I know it's going to be scalene because none of the sides match at all. Now, I don't see a right angle, but I do see this angle right here. It's definitely bigger than 90 degrees. So that's going to be an obtuse triangle. So it's going to be scalene, obtuse. Next one, number 3. Look at the side lengths. I have 2 sides that match and 1 that doesn't. That's called isosceles. So 2 sides that match and one doesn't. It's called isosceles. And then lastly, not a right, not a right, not a right, and none of them are going to be obtuse. So this is going to be an acute triangle as well. So an isosceles acute or acute isosceles. Number 4, I have 2 sides that match, and I have 1 that doesn't. So that's going to be isosceles again. And I'm looking for the angles here. I have no box to indicate a right angle, no square. And I have this angle right here, and that looks bigger than 90 to me, so it's going to be an obtuse triangle. So isosceles obtuse. The 5th example here, I have 3 angles that are the exact same, so that's going to be equal angular. I also notice that the 3 sides are the same, equal lateral. And remember, once you have one of these, you automatically have the other one because every equal angular triangle is equilateral and vice versa. Last one. I see our right angle here, so I know for a fact that my triangle is going to be a right triangle. And secondly, 2 of the sides match and 1 doesn't. That's isosceles. All right, that's the first section completed, classifying based on its side length and angle measures. So you need 2 answers per diagram. The second section asks you to actually create a sketch for the following triangles using the appropriate markings. So the first one, right scalene. So draw a right angle to start. Scalene means 3 sides that are not the same. So draw your 2 legs of your right triangle different lengths, and then just connect them like that. And then name the ABC here on the edges, or the vertices, sorry. ABC. It doesn't matter which order you put them in or where you locate them, as long as they're just on the diagram. So right scalene, so make sure you mark these 3 sides differently, and we're good. Number 2, acute scalene. Acute scalene. So I'm going to have a acute triangle, and I have 3 different sides. So 3 different sides, all 3 angles are less than 90, and I put down X, Y, Z. Now obviously the answers are going to vary depending on how you draw them. As long as you hit the definitions for both words, you can draw these in lots of different ways. Equilateral triangle, TVU. Equilateral means all 3 sides are exactly the same. So try and draw it like a regular triangle. TUV. And remember that because it's equilateral, we also know it's equal angular as well. So we're going to just draw in the 3 angles here. That's TUV. Number 4, obtuse right, JOB, obtuse right. Looking at that, an obtuse angle, like that, and a right angle, if I were to draw those, I create an open triangle. I cannot connect that. So this is not possible to draw. There's another reason why it's a little bit obvious that it's not possible. They gave us 2 names that were both classifications of angles. Okay? So when I do that, it's kind of a dead giveaway that you can't actually do it. Right equilateral. So right equilateral. Equilateral, the angles for that are going to be equal angular as well, or equal. And we said they're going to be 60 degrees. We have some confusion here because if all angles have to be 60 degrees, and this has to be a right angle, then it's not possible, right? If I draw a equilateral triangle, and they're all 60, there's simply no room for a right triangle or right angle at all. So this is going to be a not possible as well. Last one, obtuse scalene. Obtuse triangles and scalene triangles can be drawn at the exact same time. So draw an obtuse angle, Make sure the two sides are different lengths. So 1, 2, and 3 tick marks. Call it GHJ. And we have made our obtuse angle right here. That's our obtuse angle at H. And these three sides are different. So therefore, we have an obtuse scalene triangle. So to recap, triangles can be classified by either their sides, their side lengths, or their angles. So we have to know the definitions for these three for side length and these four for angles, with the knowledge that equilateral and equiangular will always appear at the exact same time. That is the end of the notes. Feel free to move on to the assigned practice.